I'm a noob when it comes to laptop electronic repair. My main focus is usually gaming consoles, and it's been roughly about a year since I've done a Joey Learns episode. What is that? Where I do it pretty much exactly that, and I throw myself in the deep end. I work on a device that I'm not usually too comfortable with and see if I can get it to work. I visited some friends at a repair shop, and they had a device that had been sat around for a very long time. They weren't able to fix it, and the customer said that the shop could have the device for spares and repair. I've then taken the responsibility of trying to fix said device. It's a laptop that simply has no power. Buckle up, because I'm probably going to say 10,000 things wrong, and if you do want to share any experience or knowledge down below in the comments, feel free. Without further ado, let's crack on. I'm going to plug in this, which works, I think. This is 100 watt power delivery for 100 watt. Here we go. So 100 watt power delivery. I'll plug that in there, and now I need to see what the situation is, okay? Well, let's see what draw we get. First off, do I have the correct connector? Oh, would you look at that? Yes. Okay, that's really, really good, because I didn't know if I had the correct one, and I do. So let me pull up the ammeter. So we've got the software now on the screen. Up. Oh, that's bumping up. What's that bumping up to? 6.5 amps? That's a big short, is it not? 6.5 amps? I mean, it's trying to do something. Is that not a lot? That's a lot. I don't know what it's meant to draw, but I'm pretty sure laptops draw around about the 3 to 5. What is this? T6? Now, I'm going to use my SSMO here, and you might be like, what? This has so many scratches on already. I don't think it necessarily matters. The goal here is to obviously just get it up and running, but it has a lot of scratches already. Like the chassis is just not in a good condition. Here we go. Okay, right. So it looks like everything's been put back together nicely. Let's see if I can measure some voltage and see what the situation is. It looks like maybe that's been soldered down there. Again, this is from a repair shop. Let's see what's going on down here. That is definitely liquido damage, because you can tell by the caps at the end. Like here. See that? And yeah. Okay. I didn't see an SSD. Could be soldered, but there is in fact no SSD here. You're right. And it's just the NVMe. Nice. Yeah, definitely some sort of corrosion going on. All right, let me, I'm going to plug the ammeter in. Oh, there's a coil missing here, and the battery's not plugged in. God, they gave me a difficult one. Hey, all right, I rate it. Battery's definitely not plugged in, to the point of how it should be. Let's plug her in. All right, battery now plugged in. But definitely a coil missing here, I think, hey? Mega ohms there. Kilo ohms here. But no short. No short. So ground this side. No short here. This is where we're going to have the main power coming in, right? Is that fuse? What's PF? Yeah, definitely some sort of liquid ingress. Look, you can see. Definitely would have had a trip in the ultrasonic. Let me just see what I draw now without that coil. I have to bear that in mind. It's plugged into the battery now. It's not making a difference. 6.5 amps. So it's nothing to do with the battery, because it's the main power rail and the battery's unplugged. I get no difference. I wonder if I need something here. What I might do is take the battery out and put a coil and see what happens. See if I get a change in the reading. It's a really tight, compact area for this battery, I'll tell you that. I obviously don't want to bend the battery. Yeah, I don't know if it's going to be missing anything else. I'm kind of thinking just take out the motherboard and attach the battery separately and see, and just start working on it that way. So therefore I can also see underneath as well. You know, 6.5 might be the max. Yeah, I would also, I could try just quickly using the thermal cam and see if anything heats up with that 6 draw. Because something's going to be going pop. Something's definitely going to be receiving a lot of heat with a 6.5 amp draw. So let me see that quick. At least I could start working around that area. Issue being as well is that if I just go ahead and put a coil here, it might make something more dangerous. So let's try and find it without putting that coil back, actually. I think that's a good shout. I've got that there. Is it that coil getting hot? Or is it the charging IC? The good thing is that I've got a component down here that's getting hot. It looks like a diode. And I've also got this chip getting hot as well. So this chip getting hot and this, what looks to be diode, is a P0103. But let me just have a look and see what the situation is. Now, it could be that it is simply meant to get hot in those areas, you know? But let me show you the components that are getting hot. I wish I knew if it had been put on the right way as well, because we don't know that. But that looks like it's definitely had solder, or had a job of solder done to it. And then another one is down here, getting a bit warm and spicy. And I think that looks like what he's tried to do is solder a wire to it and give it some voltage. That's what it looks like to me. There's a solder ball there. Is that a solder ball, or is that just, I think that's a pad. Like a test pad or something. I'm assuming this is on the right way because we have the line here and the lines here. I'm assuming that's the right way. Line here, lines here. DC voltage. Can you see that drop? and across here is 1 volt. But it's on, okay, so it's on both rails and there's no inductor here. So it's doing something. Why is that voltage so erratic? Voltage of the main power rail, I'm going to measure on that side of the diode where I got 19 volts. It's all over the place. Kilo ohms, 16 kilo ohms. Don't know if that's main power rail though. Just because it's 20 volts doesn't mean it's main power rail. Whereas on this side of where we get 20 volts, we get 14 mega ohms. So resistance seems to be okay on the main power rail. And I'm assuming that would be main power rail where that coil is. But why is the voltage all over the place? That's the question. And it could be anything. Why is the main power rail voltage all over the place? I wonder if I take the board out, if I still get that reading. Let's see what happens when we just get the board ready. Still hear it clicking. Let me see if there's something else on the other side of this board that's getting hot. Because this side, we've got a couple of areas of contention. So we've got this chip. No, we've got this diode. That's a diode, by the way. That's a diode. Sorry, that's a transistor. So I've got a transistor here, which is bad. I've then got this MOSFET, which is bad. I say bad. It's 30 degrees. And I've got this diode, which is 31 degrees. Those are the 3 main areas. Let me turn around. Could be the MOSFET. Makes sense as to why the voltage is jumping around as much as it is. What about the backside? Oh, whoa, whoa, whoa. We get a 42 degree MOSFET on the back. Whoa, 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 whoa. 43, 43, 44, 43. What's that FET doing? Because that's a lot. That's a lot more than the others. Do we have a bingo? Why is this pulling 40 degrees? 43 degrees, not much. I agree, but in comparison to everything else, it's hotter, right? So what do I get? Drain to source. 21 ohms. That's low, hey? Oh, you guys can't even see. I get 21 ohms. Gate to drain. That's not good, is it? Drain to source, not gate. If I say gate to drain, I apologize. Drain to source. 21 ohms is really low. How much resistance do I get on the gate? Kilo ohms. That's fine. But the through of 21. Well, what about these FETs down here? Because these are the other ones that we're getting hot. Oh. Well, that's shorted. Well, that's kilo ohms. That's shorted. Don't tell me that's normal. Because if so, I'll give up everything I know about electronic repair. Inject 1 volt on the output of PQ401. Output being this side, right? 0 amps. But I also get 0 amps on this side. Oh, wait. I get no draw this side. No draw that side. It doesn't matter that those 2 pins are together. Could just be a shorted MOSFET. I shouldn't have continuity through a MOSFET, should I? So let me take that off. That is in an awful position as well, by the way. I think we can all agree. It's not in a great position. I could go from underneath, right? Underneath would definitely be the safer bet. But they don't call me Risky Joe for no reason. Is it even on? I do want to measure this out of circuit. Yeah, it's shorted. That's a shorted MOSFET. So if I plug this in now, without the FET, that's plugged in. I mean, to me, that looks a lot more stable. Now, granted, I don't have the coil, nor do I have that MOSFET on now. If I go into DC voltage, measure here, 19 volts. Measure here, nothing. Because obviously it ends, right? And there's 19 volts here or here. There's 1.3 volts this side. So this is 1.3, but that might just be because I don't have the coil. I wonder if I plug the charger in now. I wonder if I plug the battery in, whether the battery will charge or not without that MOSFET. I don't know if that's a main power rail MOSFET or whether it's a charging. Yeah, 0.02 is good. Yeah, I don't think I'm going to be able to. I need to replace that MOSFET, right? I just need a MOSFET now, but I don't work on laptops, so I don't know if I'm going to have this MOSFET. Assuming it's the same as the one above it, right? But yeah, where can I find that MOSFET? I'm not going to be able to find that on the console, am I? These 2 pins, these 3 pins. If these 3 pins were bridged right here, it wouldn't matter because they're on the same rail. So you see this rail, they're all on the same rail. Same here. It's all on the same rail. So it doesn't matter if these 2 are bridged. If these were bridged, different story. Then I'm looking at this MOSFET, and that's different to that, and that's different to that. So the chances of having 3 different MOSFETs here is not realistic. I've got a MacBook board, but I don't think I'm going to have what I need on there. Lenovo 81 Bravo Del Toro. Laptop disassembly, you're telling me it's the same as this MOSFET here. This one. And then when the other MOSFET comes, I'll simply just replace it and see if that fixes our issue. The good thing is, our short's gone, supposedly. So when this was on the board, we had our issue and it was drawing like 6 amps. Whereas now, that's not happening. So I do believe that this was our issue, and I get a short through the MOSFET, as you saw, of 0 ohms. So I think it was shorted to ground on the inside or something. So I ordered some MOSFETs for this laptop. So we get 15 volts, 21 milliamps. And we actually found out that we had a shorted MOSFET on this board. So I purchased a MOSFET. I don't know if you remember on AliExpress, but I purchased the MOSFETs and they've now come. What I'm going to look at doing now is putting the MOSFET on and seeing if the laptop works. Can I just go ahead and put a PS5 coil here? Here we go, 7752. Yes, all right. It's a very similar FET. That's what I need, the 7752 part. I'm pretty sure pin 1's going to be here. Wait, I should be able to tell again, because if I just turn this around, that would make sense, Jay, wouldn't it? I should be able to see from here. Yeah. Okay, so pin 1 is top side. Cool. So I can put the MOSFET there. Like I said about the PS5, I think I'm just going to... Now, this could be completely and utterly wrong. But I think I'm just going to use a PS5 coil. I think it might be a little bit too big. I'm going to take it from the power rail. Is the board plugged in? Absolutely not. No. That's just the cable that's plugged in. Let's go 450. Put it to about 30%. Probably go with the soldering iron for this, I imagine. Okay, should we see what the situation is? I just want to make sure that I don't have a short here now, because the short was gone. So in continuity mode, the short was gone when I removed the other MOSFET, you see. So I'm in continuity mode right now. I can get my words out. So multimeter beeps. Measure here to here. No short. Out of interest, what do we have in resistance mode? Kilo ohms. Here. Kilo ohms. Here. Good. Okay. And then let me just measure the resistance on each side. Kilo ohms. It's going to be the same this side because we don't have any. We have a really, really small path of resistance. Kilo ohms. Okay. And here. Kilo ohms. Kilo ohms. Right. Technically, I mean, I don't see a reason why this wouldn't work. But like I said, this was taken from a repair shop graveyard. So there is every single possibility that they've done this and it didn't work before. So they've done a bunch of other things and, you know, took additional components off that I can't see that are missing. There is that possibility as well. But I have had a glimpse over the board and it doesn't necessarily look like there are any other components missing from what I can tell. Wonder what hot air temp, because the plastic was dead close to it. If you move the air, you're good, but it takes a lot of practice. That was 450 degrees Celsius. But if you move it, you can do it pretty well. 3, 2, 1. Okay, so we don't have the draw of it going up to 6 amps. So what I was doing before is this was pulsing, so it would be 0, and then it will go 6 amps down. It'll go across, it goes 6 amps down. It go across, 6 amps down. This is good. 100 milliamps, take the 10 off that we have for the actual cable on the ammeter. So we're looking at about 85 milliamps. I don't know whether that's good or not. I have no idea. So now all I have to do is, I guess, put it back in the chassis. All right, let me just connect the battery and see if we get anything from doing that. Not good for standby. Expect 10 milliamps or less. Let's see what happens with this. Okay, so that tells me it's not charging the battery. That something else is at fault because I get the same draw without the battery hooked up. Let me use my thermal cam and see if there's any bad heat spots for the 100 that I get. And then I can just like follow around voltage and do all of those things. Yeah, it should be enough to produce the heat. I think it's going to be one of those transistors, you know. Whoa. That chip is instantly getting hot. Look at that. Okay, that's good. Because it's the only thing that's getting hot. Except for, the Novaton chip as well. That is, that's 50 degrees. Which is too much. It looks like some sort of power management IC chip, which is good. Maybe like a BQ. Is it a BQ? Ah, I called it. So it's a charging chip. Looks like it's been replaced before. Is that pin 1? Yeah, I think it is because of the dent that we have. Are any of those bridged? Because it looks like it's been played with before. Could do with a little reflow, but these all look fine. They're just about on. Let me give it a quick reflow. Not that that's going to change anything, but I'm pretty sure that is like a bog standard charging IC for a laptop, no? I want to try and get it to move in place on its own. That's why I'm being quite ruthless with it. Doesn't look like it's going to. I think it's still a little bit lopsided, but it's okay. It's not falling into place properly, so, I mean, as long as they're connected. The joints just look a lot better now. Just plugging it in quick. 21? Wasn't this 90? Wasn't it 90? And the lead is 10. Yeah, I swear that was just 90. I'll try with the battery. See if we have any change. I wonder if the same chip is getting hot, but I can't see because the battery's on it. But it was definitely doing 90 before I put the battery on there, I'm pretty sure. I think it is. Now it's back up to 90. Now the question is it a faulty chip or is it something around the IC that's faulty? Let's have a look. Let me measure some voltages and see if anything is quote unquote weird. So multimeter is going to go into voltage DC. Pin 28, 6 volts. All right, mate. What, check that first. What rail was that? 25, 26. 25, 26, 27, 28. Yeah, I get 6 volts. 0.01 volts here. Same here. 4.4, 0.1, 0.1. We get the 17 coming in. 17 here. So I get 17, 17. 16. 0.06. On what looks to be pin 2032. This one. 5.5 volts on pin 30. I'm not going to have a BQ on any of those devices because they're not charging devices, right? Got a BQ on the switch, obviously, but it's not as big as that. It's a much smaller one. Buck boost, battery, charge controller with system, power monitor, and processor. Yeah. Well, let's just see what voltage I get here. It's back down to 21 now. Keeps changing, hey? 0.032. 0.05. Wait, so we're losing that 19. Where are we losing that 19? Because I'm sure that's meant to be 19. Wait there. Okay, so we have the 17. Here. So we lose it on this FET. So I get the 17 here. Nothing here. So the voltage isn't going through. On this gate, that's where I get the 3.7. On this gate, I get nothing. Oh. What are those? Those solder balls here, look. What? Yeah, so here, look, on the gate, I'm getting nothing. 0. Whereas here, on the input side, I'm getting 18, 19, which is what's meant to be happening. And I get 0.02 on the drain. But the gate, 0.0. Something's happening there. 0.0. Sorry, 0.4. Yeah, something's up. 18. Whoa. Now I'm getting 18 on the gate. And now I'm getting 18 here. Wait. What? 18 here. Now I get 0 here. So wait. I get 18 here. Now I get 18 on this side of the FET. 18 here. Nothing here. Let me take it out and put it back in and see what happens now. It's showing like 27, 28, but it looks like it's doing something now. It's doing like 27, 28, but it looks like it's doing something. So let me plug in the battery. Oh my gosh. She's working. She's working. I think she's alive. Well, I don't know. CPU doesn't feel hot. 2.5? That's good. I feel like I should put it, hey? All right. Hold. Now I need to put this back in the chassis and see what's going on. No way it was going to be that resistor. Do you reckon that solder ball was shorting it that whole time? Do you reckon that's what it was? Well, not the whole time because obviously we had the bad MOSFET. Do you reckon that line there is different to the resistor? It does look like on a different path, doesn't it? So this is 0.7. The resistor is 0.4. Wow, that's 0.7. This is 0.4. I wonder how long that was there for. That must have been there since I started working on it because the only thing I did was this area and I don't think I would have flicked any solder over here, nor when I pushed this down or reflowed it would it have affected here. That resistor looks like it should go downwards. Wait, yeah, is the resistor actually connected? Wait, I don't know. I don't think so. Wait, there's no pad there with that resistor, is there? Oh my gosh, you guys are right. That resistor is meant to go to that pad. Wow. Now, this is in a really delicate area here. And this is the issue, isn't it? Because this is a donor board from a repair shop. So, and they didn't tell me what the situation was. I said, have you got any? And they said, yeah, take this one. I have no one to blame but myself. Yeah, probably chasing the short and moved it. Agreed. Definitely goes to that pad, hey? No, I'm going to go from underneath and just move it quick. Yeah, other side's fine. No plastic, nothing. So maybe that explains the whole gate situation because where's that resistor connected to? The gate. So not only was this resistor not connected to the gate to allow some sort of pull up or pull down voltage or whatever it might be, it was also bridged to this little ball here, this little test point. How on earth? Wow. Great. By the way, Bridger, great spot. There's no way I was spotting that. Let me just see what happens now. Yeah, the same. We have the same. So it's doing like, that probably looks a bit healthier now, hey? It's a little bit all over the place. And then when I connect the battery, we should be okay. Oh, we're still getting that big draw. Yeah, I can feel components warming up. What's that big draw there? What are these two big draws, do you think? Do you think that's it just like attempting to turn on or something? 3. Keep an eye up on here where we got the ammeter. 3, 2, 1. Wow. I mean, that's a healthy draw. There's a dip. What's going on my camera? That isn't healthy. Is it not? That's a lot of amps. Or what is it meant to be? Yeah, I thought battery was charging as well. 3.25 amps. It says 3.25 amps on the back. 20 volts, 3.25 amps. I can hear it clicking. There's no light on the power button to indicate that it's charging, but I don't know if there is another light somewhere. Wouldn't pull 3 amps to charge, would it not? Something's clicking. Something's clicking. There's a screw there. It's still clicking, by the way. I can hear it clicking. It's a MOSFET making the clicking sound. Yeah, an audible MOSFET. Things I've never heard of. It's faster now. What? I don't know what's going on. It's now a different MOSFET. So the one that I marked gold is here, but the one that's pulsing is now the one that is above the one that I replaced. You see that? I thought it was this one. Wait a minute. Let me put the battery in because I need to know. It's the whole circuit. It's all of them. It's all of those MOSFETs. Why are they? I mean, that looks really good actually in terms of being able to read them. Why are they all different? Should they all just be 7752s? So we've got the 7752 here, 7752 here. Then we've got a 16 GUD. Then we've got a 7401, a 7408. Under the MOSFET, under the resistor you rotate, it looks like the pads could be bridged. You talk about here. I think they're meant to be bridged though, right? I changed this one with a new one that I bought. I changed this one. And this one, I need to find out the original components. So I've got 7752s now, so I can just replace, but 250 ohms through there. What? So it looks like, are you telling me this was meant to be like that? Or is this shorted because of everything that's going on? Like, is that blown? Because that was kilo ohms, right? Before this was kilo ohms, whereas now we've got 252 here. We've got kilo ohms here. Wait, we've got kilo ohms here as well. So we've got kilo ohms this side. So source drain is kilo ohms, but through is nothing. Unless it's meant to be like that. The resistor is just a throughput, acting as a fuse, right? Doesn't connect to that inductor, it goes somewhere else on the board. Measuring dynamo, source to drain, of course. Nothing. Other way. Nothing. Whereas this one, climbing, goes up to 3. 0.18. Let's check these ones. 0.18. I don't know what's going on with this, and it's getting a little bit difficult, isn't it? By Diagnostic, right, we've got this MOSFET which has been replaced. Just to recap, right? So this MOSFET's been replaced by myself with this 7752, which is what it's meant to be. This one, 7752. So technically these are okay, but this was pulsing a second ago without the battery plugged in. Then if I go up, I've got this MOSFET, which looks like it's been soldered on. So I don't know the true value of this. And then we've got this MOSFET here and this MOSFET. This is a 7408. This is a 7401. Again, if you look at these, it looks like they've potentially been soldered. So I have no idea if these are like true to what they're meant to be or whether they're different. And because I've picked this up and it's a donor, I feel like there's maybe been a little bit too much done to it for me to carry on and try and diagnose this. If I knew the exact history of what was going on with this laptop, I think it would be a little bit better. Because I don't know the history, it's making it very difficult. It's been into before, someone's attempted to repair, and it's been chucked in a donor pile, and it's had corrosion damage. So I don't think it's a good use case, to be honest. I think I should put this one away and call it quits. So I ended up doing exactly that, and now I've begun my donor board laptop pile. Everybody has to start somewhere, and I felt like this repair for me personally was just a little bit too complex, and given the scenario and situation of it being a donor board to begin with, then I think it makes sense to give up the ghost on this one, unfortunately. Any of the tools and equipment that I use today, I'll leave down below as an affiliation link, so I get a bit of a kickback if you were to buy something from AliExpress or Amazon. Thank you very much for watching. If you did enjoy, hit the thumbs up button, subscribe to the channel if you're new around here, and as always, I shall see you in the next one. Peace.